Right, so hope everyone enjoyed lunch and the morning sessions. Now we're going to switch gears to something completely different. We've discussed, like public understanding of risk and what's the risk or the possible risks that nanotechnologies can actually have into the environment, to our lives. Now we're going into something completely different, which is the resilience of our environment. How do we sustain our resources? What approaches we have to do that? And we couldn't have thought of anyone better than Veena, who came all the way from Australia. I know she has a super busy schedule, as always. Veena is the type of person that you see again and again in the sort of different big conferences, delivering keynotes. And then we're really delighted that she's here with us today. She's leading the Center for Sustainable Materials Research and Technology, which stands for SMART in UNSW. And without any further ado, Veena.
Thank you. Thank you very much, Themis, for that very kind introduction. Themis and I met, in fact, at one of these keynotes where we were both doing keynotes in a plenary session at EMRS. So you could say he travels the world doing keynotes at plenary sessions across the world as well. And I guess that's really part of the privilege and the joy, in a way, of meeting colleagues from all over the world. And I'm really so delighted and privileged to come along and meet all of you amazing, smart, brilliant people. When I heard from Themis about this program, I was absolutely on board, wanted to come and meet all of you, and really super delighted. I know I got to see the brochure that Themis gave me on the Lloyd's Register of various students doing different projects. And I think I've got to say it's one of the most impressive collection of research projects that you will ever see in the world, because I think one of the most important things we can do as researchers is think about how our work, our research can actually have an impact on this world. And I think, to me, it's an absolute privilege when you get a chance to work on projects, and it's an even bigger privilege when you come together as a collective group like the way you all are, to be able to build lifelong friendships, but to really exchange ideas from across the world. So it's indeed my privilege to be here today. So as Themis was saying, I mean, our work has been very much about understanding, that if we are going to be, using products and devices and systems in our everyday lives, whether it's our phones, just look at how many of you are sort of, with your phones and computers. Just think about what it means in a holistic sense to our planet. It just means that from our point of view, if we just depend on making our products, and then, of course, at the end of its life, not worrying about what happens to the products that are left behind, or it just is a huge, huge burden on our planet. But just because a phone stops working, that doesn't mean that the materials in there are no longer useful, right? So we know very well that a lot of our systems are really complicated in the way they contain different types of metals, plastics, ceramics. So how do we possibly, get to all of these exciting materials, and how do we make sure that there is security of materials in the long term, so that we don't end up in a situation where we've sort of, mined all of our materials, and then we've created a whole pile of rubbish at the other end, and somewhere in there we've just used our phones and our computers for just 2 years, or whatever it is that people use their phones for. So why don't we switch it around? And so I always sort of say that your phone is effectively a collection of all kinds of very interesting and valuable materials. And those materials really never die. It just happens to be a phone for a certain part of its life. So let's think of it this way. These are all materials that are here forever. We're just putting it into different forms and shapes. So when we think about how we're going to achieve materials security, one simple way of looking at it is that we never put anything ever into landfill, so we never waste anything. Now, I know it's sort of sounding like a really sort of massive dream, because the world is literally drowning in many instances in waste materials. So how do we actually achieve that goal? How do we achieve the goal where we don't put away anything into landfill? How do we achieve the goal where we make sure that we're able to continuously produce valuable materials and not see end-of-life products, whether they are your simple plastics or indeed they are glass, and don't see that as a burden, right? And don't sort of say, oh, well, this product is too difficult and really we shouldn't be using this product. But the reality is that we all know that we as consumers, we as society use all these products, whether it's our phones or indeed our cars, right? Even something as basic as your windscreen glass in your car, it might appear to be a nice simple glass, but of course it's not. It's a safety glass. Well, why has it been designed to be so complicated? Obviously, it's been designed that way to keep us safe in case of an accident. So it is important that we start to recognize that in that entire sort of thinking around materials and products and this planet and people, we need to first and foremost have a very holistic approach towards the way we see, our role as researchers, no matter what we work in. But I think more importantly, we need to ask the questions, how is it that my work could potentially then make lives better for people on this planet? So ultimately, whether it is safety, environment, medical, whatever the case might be, I think it's about asking a whole range of different types of questions that allow us to say, right, if we had to come up with a solution, in my particular case, when we started on this journey at the Smart Center about a decade ago, we had journalists in Australia when I was presenting this work, and sometimes, you tend to sort of get a bit sort of overwhelmed because you feel like no one seems to get what you're talking about, so you're sort of thinking, am I alone here? Why are people not getting this? So in the early days of the Smart Center, it was a bit like that. We started with things like waste tires and plastics coming out of the automotive sector, and we wanted to be able to utilize these types of materials. And we all know how challenging even something as basic as tires can be, because you probably have seen stories in Australia recently. There have been many examples where tires and plastics and so on have been stockpiled. These have then caught on fire, and that's then caused a problem, of course, to our communities. So, we ultimately know that there are lots of challenges associated with it. Why do we ignore the fact that we've got all these useful materials, but yet we choose to let it sort of out of sight, out of mind, we'll sort of bury it somewhere and we won't think about it. But if we could actually imagine a situation where all of these materials, whether they come from our cars or our electronic devices, if someone said to us that you actually have no more material and you've got to actually have a mass balance on your planet where you have to recycle and reform and reuse all your materials, and you're not allowed to mine anything out of the ground, well, we would become really very careful and conscious of how we use our products. Whereas right now, we've become too used to the whole principle of linear economy, right? Which is basically I make something, I use it, and I throw it away. And well, actually it's somebody else's problem to worry about what happens to the end of life products. And in fact, in Australia, we recently had our own little sort of crisis, where it was kind of not just little, it was kind of big, because last year when, the public awoke to the fact that we were no longer able to send our waste plastics to overseas destinations, places like China, where we were sending our waste plastics away to, I think everyone was horrified that we put in a lot of effort in collecting and sorting in our homes all these different types of plastics and glass bottles and so on. But yet what we all did not realize is that the companies who were the waste management companies were simply sending a lot of these materials away overseas. So ultimately for people, communities want to be a part of a solution where they want to see everyone do the right thing. And I think the reason why we're hit upon this crisis is because, no surprise, right? Countries like China are going to say, well, wait a minute, we've got our own waste to worry about. Please don't send us yours. And so I think if you start to actually put logic behind all of that, it makes a lot of sense. It says, well, it's your problem. You created all of that. Why don't you think about how to, sustainably manage your materials and resources? So if we stop thinking about it as a waste, and of course, we do in Australia, generate a lot of wealth from mining. So why can't we think about mining these types of waste materials? The only difference is instead of being underground, these waste materials are mines that sit above ground. So it's really just sort of shifting the mindset and going, we value these materials. And of course, why should we value it? Because we need our metals like copper. We need our materials like rare earths. We need all of these materials to manufacture our devices and systems. So this is really where, for us, the journey has started, where we want to be able to understand, can we actually apply a whole new way of actually manufacturing? Let's not even talk about this as if it's a waste management problem. Let's actually talk about this as it should be a manufacturing challenge. If we are going to take it back into a circular economy where we're going to put it right back into production, well, we can't just assume the same old sort of smelters in the way manufacturing has been designed in the past of making metals, for example, is just going to be the same old thing. We need to be able to then say, right, if we are now going to have to deal with all of these waste resources that are generated across the world, can we actually imagine a whole new way of manufacturing? And what that then means is that instead of thinking about everything being bigger and bigger, right? Economists talk about economies of scale. Instead of always thinking about it from that point of view, can we actually think about it from the point of view of what is the purpose? If the purpose is to make sure that we recycle and reform our materials, we minimize pollution, we minimize harm, we make sure that we have security of materials, then it's not always about everything being bigger and let's have a grand big smelter and we throw everything in there and hope for the best, right? It is very much about saying every community and region and town and city in the world should actually be able to transform their waste resources into valuable materials. And it shouldn't just be the responsibility of a few big, large corporates who can kind of make those decisions about this is how we're going to deal with waste, but rather why not us looking at the possibility of transforming locally available materials. So if you're in a small town where you might be collecting a whole lot of phones and computers, that's no different to being in a large city. The only difference is the volumes are different. In a larger city, you might have many more phones and computers to collect, where in a small town, you might have relatively few. But could we not design and think about manufacturing technologies that were actually scalable? Not just thinking about scaling up, but scaling across, up and down. So could we imagine actually having small scale manufacturing that are still profitable? And that's really what microfactory technologies are all about. We actually demonstrate that if we can control the way we make our materials, the way we transform them at a micro scale, then there is no reason why we can't imagine a future where you can actually have microfactories still able to produce highly valuable materials that are profitable. And this is really where the difference is, and the key is in these types of materials that are expensive and valuable, you can actually set up microfactories on a small enough scale so that you can transform different types of waste materials, and we can all then look at the whole world participating in a way, a global supply chain. Why not? If you've got one component being made in one part of the country, but you've got another product, a semi-finished product being made somewhere else, you can actually think about how you might create jobs and opportunities for different regions, and people can actually be part of that entire supply chain. So that's really where in Australia we've taken a little bit of a different shift in the way we start to think with our manufacturers. And you might say, well, okay, that might be well and good, well, let's wait and see which manufacturers put their hand up. We've actually seen big and small producers, large manufacturers who've been around for 100 years. We had one steel company who celebrated 100 years last year, to relatively tiny companies who are in the recycling business, are all saying, well, wait a minute, if we can add value, if we can create new materials and new products, we need to be part of that. So it's about thinking about not just suddenly, I'll stop doing what I've been doing for 100 years and I'll start doing something different. That's not what we are advocating. What we're talking about is, are there opportunities to use skills in the way materials are made and processed and the way materials are put into applications? Are there ways in which we can all work together? So very much a collaborative economy. And one of the examples that I'll show you as I move forward with these slides, and you'll see, and I'll explain in just a moment as to what we're looking at here, in a way, it's an ecosystem that we've created as part of what we are trying to show you here, is life is complex. Yes, of course it is. We create all kinds of materials as waste. That's because we as human beings use all kinds of materials and products, right? So I'm sure you've heard of organizations like Nespresso. Well, okay, so aluminium is their choice of material in which they use, they use to make coffee pods. So you might say, well, why are they using aluminium? Well, they use aluminium for whatever reasons they have, which is about, the quality of the product. But it may not be such a bad thing if you can actually think about, again, aluminium as a metal that is recyclable over and over again. So if you can actually think about how you might be able to take aluminium in different forms and shapes, bring it back to life in different products, there is nothing wrong with that. In fact, in this particular instance, we're also working with people who are in the plastics business. And they have a lot of rather difficult plastics. For instance, the one hard plastics that come out from our printers. And in our printers, don't forget, we also have cartridges. Cartridges are, again, plastic. In that, we've got, our toner powder. And the list goes on and on. There's all of these things that come out of our homes and our offices. I know if I start to give you a long list, you might go, oh my God, that is depressing, But on the other hand, let's look at this as an opportunity. When all these materials come to us, whether it's aluminium or whether it's this high quality plastic, it's about actually imagining and let our creative thoughts go wild in terms of what it is that we can channel it into. So it comes down to materials and processes. And we need to be able to combine those two. And that's why when we think about microfactories, our e-waste recycler, for instance, in this case, on the top right-hand corner, you'll see e-waste filaments. These e-waste filaments are actually plastic filaments that have been produced from their plastic waste. And we have directly gone from waste to a value-added product because these plastic filaments cost a lot of money. So you can actually go and purchase plastic filaments for 3D printing, and you might pay $20, $30 a kilogram for it and upwards from there. Whereas remember, we started life for that particular feedstock as a complete waste that people didn't know what to do with. And this was sort of put in the too hard basket, right? So if you now start to say, well, if we could transform something like plastics that was seen as a dirty feedstock, with all the toner powder and everything else in there, and now we're putting it into plastic filaments that's worth a lot of money. Well, why is it worth a lot of money? Because that is the feedstock filaments that go into 3D printing. And of course, as people do more and more 3D printing, they'll depend more and more on these types of filaments. So we don't have to go back and tap into virgin plastics and, create more plastic waste, but rather look at how someone who's got a stockpile of waste plastics could actually become a producer of plastic filaments. In fact, our e-waste recycling partner in Sydney, that's TES Australia, they had actually never done manufacturing before. They're basically an e-waste recycler. They're just a recycler people who collect and send waste away to somebody somewhere else. Imagine now if you can have companies, big and small, saying, wait a minute, I've got this waste, I can actually add value to it. I can do something really clever with it, and this way I can make more money as part of the fact that I've got the care and responsibility for this material. Because remember, throwing away waste is also not free, right? For example, in places like Sydney, it costs more than $100 a ton to put it into landfill. In places like Queensland, where they've just started putting landfill levies, it could still be up to $70 a ton. So you've got enormous cost associated with disposal of waste into landfill. So the question is, what we're basically saying here, instead of just throwing money away, literally into landfill, why not have these producers look after their materials, apply clever science, and in fact make sure that they can transform these into useful products for which there is demand. So when we talk about that holistic solution, it's not just recycling for the sake of recycling, it's about understanding, well, what does society need? In the same way, we can start to look at what you see at the bottom right-hand side, rare earth oxides. So again, rare earths, very important. People worry about where all of this is going to come from. Well, there's a lot of rare earths in our hard drive magnets. There's a lot of rare earths in our batteries. Why aren't we looking at all of these materials, and why aren't we processing those? So the list goes on. And what, of course, is complex in all of this is that you've got a whole collection of different elements in different forms, different compounds. So, of course, the traditional ways of smelting and producing materials just doesn't work. We have shown that from our waste batteries that contain a lot of zinc and manganese, where the compound might be quite complicated, you can actually convert those into zinc oxide and manganese oxide as an example. So you can actually create really useful materials. We can take a combination of waste glass and waste plastics. So remember, I was talking about automotive sector, and in fact, even in the electronic sector where you've got glass and plastics together, you can think about taking that silicon from glass, taking your carbon from plastics, and you can actually combine that. If you could find a way for this to react together, you could be producing silicon carbide. So you've suddenly got a whole range of possibilities where before people just thought about it as, oh, it's a piece of glass. It's very difficult. I can't mix automotive glass with e-waste glass, with architectural glass. There's so many different types of glass. Even something as simple as glass is actually not that easy to recycle. So when you think about, glass producers who basically say, wait a minute, you know what? I won't have that glass, I won't have that glass. That's what makes it difficult. You can't allow for that cross-contamination because chemistry could well be different between these different glasses. So it sort of makes sense if you actually start to unpack it and say, if I'm in an area where my business is actually collecting a lot of broken glasses, because there are people who replace window glass in a car. Now, why should that window glass repairer just looking at throwing away that glass? Why not look at the transformation of that glass into materials like silicon carbide that we just talked about? Except for this manufacturer, it's not possible to have a huge investment in setting up a big factory. So if the focus is very much on creating value, you can do it on a small scale as long as there is quality and performance of these types of materials. So again, it's challenging the notion that just because you've got a whole lot of waste mixed together, oh, well, it must be poor quality product. Well, that's not the case at all. So in fact, in many instances, it's very important that when we work with our manufacturing partners, that we actually make sure that we have got the right quality. We need to make sure, whether it is your plastic filaments that I was talking about. You can't just say, oh, I've made any old plastic filaments, it's fine. No, it's got to be good enough for 3D printing, if that's what the purpose is. If you want to be able to produce different types of metal alloys from your printed circuit boards, that's what that PCB is, then you need to be able to say, okay, wait a minute, I need to have the alloy of the right chemistry. Only then the end user will accept it. So in all of this, it's about the quality of the product, and we should not assume that just because it's coming from waste, that it is automatically poor quality material or a poor quality product. And that's in a way the challenge for us, that we have to completely redesign the way we manufacture our materials. So the reason why we call it selective synthesis of materials from waste is because actually think about your waste resources as a warehouse of all kinds of elements. What you're really doing is you're being very selective in designing your manufacturing process. And by that, you may wish to control the temperature so that at a certain low temperature, you might produce an alloy that can be readily produced at a certain temperature of, let's say, 400. Now, you've got material elements like tin that are present on your circuit boards. But on the other hand, if you actually imagine something like copper, which needs to be produced at much higher temperatures, you could selectively control the temperatures and the process conditions where your circuit board suddenly gives you alloys, whether they are tin-based or copper-based alloys. But the important goal there is not to just assume I've got a grand big smelter and I'm just going to throw everything in there and I'm just going to have everything mixed up together. So the word selectivity is important because it means you're actually targeting exactly what you want and you're controlling the process to give you those types of outputs. So in a way, what's interesting is challenging the notion that the traditional ways in which we've always thought about smelting, and even like, for example, with plastics recycling. In plastics recycling, people would sort of go, oh, well, I'll have to go to a guy who makes pellets and I'll buy those pellets because I can then put that back into my manufacturing process. But if you're a plastics recycler, like we did with TES, and you know how to deal with your waste plastics, and you know what's in there, you can actually control the quality of the output, and you can in fact make those filaments better than going through a traditional pathway for manufacturing plastics. You could take it a step further, and you might think about, wait a minute, I could be designing all kinds of filaments, right? I could design the ones that contain metallics in it. I could design all kinds of filaments for specialty applications. So in fact, that's exactly what we're doing. We're not just thinking about the stock standard products that are available in the market. Where we have gone off on a completely different pathways, we've innovated the kinds of materials because we know that we can produce those at an affordable price. So plastic filaments can vary, as I said, from as little as $20, $30 a kilogram, and they could go upwards from there. Now, if you want to introduce metallic particles like copper in it and carbon particles and so on, of course it's going to get more expensive. But what we are basically saying is that if you're an e-waste recycler and if you've got access to all kinds of valuable materials, why shouldn't you be thinking about creating innovative products? And that's where microfactories are different. And in fact, the whole science that we are developing here is the science of micro-recycling, allowing us to zoom in and focus on each of these different types of products. Some of the plastics that are challenging, that are complex. Let's take, for example, the one I talked about, which has got mixture of toner powder in it. This toner powder, as you know, comes out of your cartridges, the printer cartridges. Guess what? The toner powder costs a lot of money to dispose of in landfill. So if I'm actually a recycler, what would I rather do? I mean, that's a no-brainer, right? Why would I pay money to dispose of into landfill if there is an alternative? So what we are really looking at is what are the valuable metals, and iron is one of the metals that's present in a slightly complicated form in that toner powder. And if iron is such a useful material, well, again, an obvious market for that is a steel producer, because in a steel making furnace, you've got iron. So why not channel that complex mixture of plastics and toner powder and all of the stuff that society calls as the dirty plastics, and channel that to someone who can use those elements productively? So this is really where the journey of actually what I like to think about this is not a typical sort of vertically integrated supply chain, but rather what I'd like to think about this is that we've actually got a horizontal integration. And that's where, of course, microfactories work well. Because if I'm in a small community, I still have my coffee pods, I still have printers, I still have phones, I still have all of these materials in there. So what those bigger pink sort of circles in this Venn diagram is supposed to indicate is availability of these resources. And if we start to think about our waste materials as resources, and I've indicated they're glass and tires and plastics, and of course the list goes on, around them in those green circles are basically producers, manufacturers, all of the people who actually do such an important job. What we need to do as researchers is think about how we create this whole circular economy that looks at ways in which our different elements and materials can be put back into production in a way that we do not pollute our environment. And that's the important point. And that's the only way we can help our manufacturers, help our recyclers, waste companies think about the fact that there is a lot of value locked up in our waste materials. And that's really what I guess the future needs to look like. We need to be driving that change in terms of no matter where we sit in this circle, whether we are people who actually have got resources, whether we are indeed people who are designers and producers, or in fact end users. We all sit somewhere in that whole circle as researchers, as people who collaborate with each other. Can we actually imagine that we might actually enable a whole new shift towards new economies being developed, where instead of throwing these materials away and just looking at it as a burden to society, we can actually put them back into a whole new circular economy solution. And this is why, of course, we need to work together. The collaboration is, just like we as researchers collaborate, can actually also happen between different organizations who may never have worked together before. So where in a supply chain can you imagine a plastics recycler looking at the possibility of becoming a supplier of raw materials to a steel company, to a metals company. You would not actually think about that, because normally you would think about the fact that if I'm an ore mining company, I might supply into a metals production company. But here we're talking about the possibility of different companies, different organizations working together. And this is where, of course, research can play such an important role in enabling those new solutions to come together. We need to also bring on this journey end users right from the very beginning, so that they can see that there are lots of valuable resources that we have on our hands. And so for the Smart Center, it's been very much about, if we encapsulate all of these principles around creating value-added materials, around minimizing the transportation of waste. I mean, when we talk about, moving waste from one area to another, because we think, right, the only solution is we need to put it away into landfill. If we actually create these microeconomies, then what we would have enabled is we would have actually allowed new types of jobs to be created in so many disadvantaged communities globally. And that's really where the difference is. You can imagine, if you're in a disadvantaged community in some part of the world, you can't expect, a massive conglomerate to come in and set up their business in that region, because they might just see it as economically not viable. But you can imagine now, if there was a possibility of creating microeconomies through these types of microfactories, government partnering with businesses could well set up businesses that allowed us to create value from waste, create local economies, and creating local jobs. So we are, in a way, starting to think about not necessarily the traditional, the large economies of scale, but rather let's start to think about economies of purpose. Because the purpose here is to make sure that we protect our environment, we protect our people, and we enable equity and fairness in our communities across the world. And if we're going to have those ambitions for everyone on this planet, we need to be able to make sure that our technologies and our science enable that to happen. And I think, to us, an example of what we're doing with our microfactories could well be just one way of achieving that. There may well be many, many other ways. You could be thinking about distributed manufacturing. So that's another aspect of what we do with our microfactories, where we look at the creation of different types of materials from waste. And of course, the ability to create those types of value-added materials means we need to be sure that it's going to perform well, it's going to have the right properties. And this is why, of course, working with end users is extremely important. The materials that we are ultimately creating, we want to think about it as, going beyond the traditional 3 R's: reduce, reuse, recycle. As I was driving into NUS, again, I saw the 3 R's written up there, and it was really nice to be able to see that. But of course, as we know, not everything is as simple as converting a simple PET plastic bottle into another PET plastic bottle. With some products, it is possible to completely recycle it into the same product again. But if your products are complicated, like what we've been talking about, then it is not necessarily as easy as converting back into the same product, which means we need to think about a 4th R. And this is where reform comes in. What we are doing is looking at ways in which we might be able to reform the structure, the chemistry, and give it a whole new life and a whole new purpose. And we are going to have to do that, because we know our products evolve with time. We know our demands change with time in terms of how we design and develop products. But imagine if we could be doing this collaboratively. Imagine if we could have designers working with manufacturers, working with end users. That would be a fantastic way in which we could create an ecosystem. And that's really where, of course, in the Smart Center, we try and bring everyone to work together and collaborate together. So we've got industrial designers, we've got people who deal with waste, we've got scientists and engineers and businesses who are, of course, keen to look at manufacturing and developing new products. And so for us, the fact that the science then can be trialed and tested in real-world applications through pilot trials, and ultimately the goal being to work with our industry partners to take it out into commercial applications, is an important part of that journey. But the answer is never as simple, right? There's got to be an iterative process between, on one hand, what these materials do when you actually put them into commercial production, and it doesn't succeed on day one, and you've got to come right back to the drawing board and imagine how you might be able to create that whole solution ecosystem. And this is why, again, collaboration between various, organizations is also extremely important. So ultimately for us, the whole journey around this whole sort of fourth R that we call reform is absolutely essential. If we are going to reimagine, if we are going to innovate, we can't just think of, as has happened traditionally, that there's the waste management company that kind of comes in, worries about our waste and they take it away, and our job is simply to be able to make materials, use it and throw it away. We cannot imagine such a simple linear economy being sustainable for our planet. So the fact that we can indeed allow ourselves the luxury of collaborating and working together means we need to think that at every step of the way on this whole value chain and cycle of life of materials, that there are new ways in which we can bring materials back to life over and over again. So I think this is why we need to think about waste materials not as waste materials, but rather as resources. And once we put that hat on, then we can actually start to think about why these resources are important. Now, here's a simple example of e-waste, right? So when we think about how much e-waste, millions of tons of e-waste, and I don't need to tell you guys, the number keeps going up. And of course, people might say, you look at the number for Australia, and you might say, well, Australia is a small country in terms of its population, but the amount of waste that we create is still per capita a huge amount. So we need to, of course, start to think, how can we all take the responsibility together? And if it means for Australia, for example, where we might not have as much manufacturing as other countries in the world, there's still nothing wrong with us imagining how we recreate and reform our materials and be part of a global supply chain. And I think, to me, once we can create that type of ecosystem, we will, of course, enable respect for our resources. And that's exactly what UNEP does, is it identifies, the value of these elements and materials that are locked away in our electronic devices and systems. So, of course, we have to first and foremost recognize that we probably need to do a whole lot more in Australia compared to what we're doing right now. And as part of that journey, we have started in our state of New South Wales a circular economy innovation network. This is at the state level, and at the federal level, there is also a lot of work that is happening in enabling this type of conversation across different stakeholders, like we've talked about, across researchers, local governments, the local council, people who come and collect your rubbish. They need that support in terms of what's going to happen to materials. We need to bring businesses into picture. And if we've got that type of buy-in from everyone, then we know we're going to truly achieve that material circularity. And that's really what circular economy is all about. It is all about also recognizing, as the slide says, that there is a lot of money that's embedded in these types of resources. There are whole new pathways to developing new microeconomies if we are really clever and smart in the way we view these materials and the way we actually create these new economies. So here's an example of what we see, for instance, in the middle there is basically typical warehouse. You've got, all of these there that are there, not just in Sydney, but in all parts of the world. A lot of our resources get collected. Yes, in some instances, the computers get refurbished, software is updated, and they're put back into reuse, and that's fantastic. We have to be able to reuse it. And businesses like TES, with whom we work with, that's exactly what they do. They will provide that reuse service. But what we've got to recognize is that it's not just the whole computer being thrown away. Sometimes you'll have parts. You have RAM cards, graphic cards, hard drives. There's lots of different components in there that we need to, of course, be mindful of, that it's not just as simple as, here's my old computer, I'm just going to throw it away, but rather be mindful of where these value-added transformations can occur. So where we're working with organizations like TES is not just to look at the plastics that I was talking about, we're also looking at the potential of batteries. We know batteries also contain really useful materials. So just to be able to give you a little bit of a sense of what happened last year, as I said to you before, in Australia, which was when, of course, the ban came about, or the limit in terms of the quality of the materials that we as a country could send to places like China, and of course the National Sword Policy, which some of you may have heard of. But if you haven't, what it is basically telling countries like Australia that we are going to put a limit on the quality and the purity of the plastics that you can send to us. So the level of cross-contamination that we will tolerate will be a certain amount, which means there are strict conditions. You cannot send us all the dirty cross-contaminated plastics. We only want the clean materials. But if we're going to go through all of that effort, in taking care of our waste, we're going to put systems in place, then we might as well start to look at the whole challenge holistically. What if the standards get harder and harder to meet? We can't always be relying on other parts of the world to help solve our problems. And this is where, of course, the problems need to be addressed. But of course, it's also important to recognize, yes, things like plastics and tires are combustible materials, and they do catch fire under some instances, which means it can pose a health risk. So when we talk about a lot of these materials that are combustible, we all have got examples that we've heard and read about and seen, whether they come from our materials that go into our cars, electronics, building products. If they are materials that potentially can cause risk to human lives, we need to keep that in mind. So waste is not just a little harmless pile of plastics or tires or something that we can put away. We need to recognize that materials are, of course, risky if they are simply allowed to, collect or indeed used incorrectly. So for us, it's about recognizing that the old way, which is, you'll see that line across the screen there, which was previously materials being sent to overseas destinations for processing. Now that there is a limit and a ban on some of those materials, what recyclers, of course, are recognizing in Australia is that we need to actually start to become producers, manufacturers, and we need to start to create that circular economy where we can produce materials. And of course, if we can do that, then it gives Australian economy a whole new way of thinking about the waste resources. So for example, whether we are about creating these new valuable products and whether we are in fact enabling economies to flourish at the local level, what that then means is for us, it's giving us a whole new way to think about these challenges. And effectively, from our point of view, it's encouraging more investment in these types of businesses. That's what businesses big and small are doing, whether they are, recyclers or metals producers, looking at what the future holds. If there are valuable metals to be made out of our waste resources, why wouldn't you do that if you're a metals producer? Why wouldn't you position yourself targeting and looking at future metals, critical metals, and a lot of other metals that are needed in our electronic systems? So there is a reason why businesses actually are paying attention to a lot of these scenarios. So of course in Australia, and of course this is valid across the world, where we've talked about, our responsibility towards the planet. We've talked about our responsibility towards people. We can't simply send away waste materials in countries, places where, of course, we know and we've seen all those horrific images where, people are burning away our e-waste materials, burning away the plastics so that they can tap into metals like copper. We can't allow that to happen. What we need to have are safe and sustainable technologies, and we need to make sure that these types of technologies are affordable. It's no point having a solution that can only be affordable by some. And I guess this is where microfactories are different. We need to think about how we're going to create these types of systems that can take locally available waste materials, but not just see, different parts of the world as, okay, we'll just put it off on a ship somewhere and let it disappear into some other country. In fact, ABC, that's the Australian Broadcasting Corporation, did a show and very successful one called War on Waste. If you guys are ever interested, go in and have a look. And I think to me, it was actually quite exciting because even though I'm someone who works in this area, it was really interesting to see how you could track some of the TVs that we all felt we put into our bins, collection systems here in Australia. But a lot of these complex electronics were ending up in different parts of the world. Of course, they tracked that by putting in GPS trackers in the waste. And so, of course, what's interesting about all of that is it was a revelation for the Australian public to be able to see, well, this is what happens to our end-of-life products. So, of course, on one hand, we can say, well, we're all equally guilty, right? Because we all are consumers. But on the other hand, we can actually take on actions and demand actions where we think that governments can play a big part in how this can actually transform our societies. And that's really where, of course, when we talk about what does it mean, this whole collective economy, it just means that we all need to understand that in this whole sort of circular economy that we're talking about, where we shouldn't be throwing away materials in the old-fashioned way in which we thought about a linear economy, we need to actually ask our question, are we doing enough as researchers, and are we creating that impact by even asking the right questions? So the fact that the public sentiment in Australia last year when all of this came to light was so strong that in a matter of a very short time, the conversation has shifted dramatically. So even recently in the papers in Sydney Morning Herald and so on, conversations around state environment ministers looking at what we might be able to do. Can we do things better? Can we improve practices? So I think once you start to see the public sentiment starting to grow in this area, governments and businesses and everyone will come together to find a solution. And that's really what we are starting to see. So as a result of that, of course, suddenly we see this interesting spike in a lot of people wanting to come and see our microfactories. And that's been a good thing. That's been a real positive that, from councils, governments, to mums and dads and kids, everyone who wants to come along and have a look at what our microfactories do. And I think it's been fantastic to kids in high school who want to come along and participate and look at what we do. So here's an example of what we have at UNSW. This is the smaller version of our microfactory, fits in about 50 square meters, what you see there. In fact, on the right-hand side of your screen over there are a lot of servers collected from UNSW. So you can say we are our own microfactory on our campus where we take in a lot of these difficult materials. We take in batteries, hard drives, and so on, and we look at that transformation. In the middle there on the screen and the furnace behind you is where the hot end happens, as in we're creating metal alloys. So that's what you see on the TV monitor, and on the left-hand side of your screen is where we are processing plastic. So the idea there, of course, it's being done on a really tiny scale. It is a pilot facility. What we are now setting up in the basement in our building where we are located is actually a bigger facility fitting into 150 square meters, allowing us to actually show what a commercial outfit would look like. So it's basically saying, right, if an industry partner came in and wanted to set this up on a commercial scale, how would they operate it? What would they look like? So from that investment perspective, because if businesses come in, they go, well, what would it cost me? How much time would it take to skill and train people? So there are all of these interesting questions that we get. How are we going to make sure that we're going to operate these machines safely? So there are practical questions around safety and new systems that we're putting in place. So to demonstrate a lot of that learning, we are actually setting up the microfactory in the basement that allows us to take on the larger modules and to be able to demonstrate how it can be done. So from our point of view, what the microfactory really enables us to do is let's start to look at how we unpack that value that's embedded in our resources. And of course, where could this possibly fit in terms of our global supply chain? So this example here basically shows you what our filaments look like. So on the left-hand side, you see plastics coming from our e-waste. You can see in the middle are the filaments that we have produced. These filaments then get fed into our own 3D printers, and we print our products. Now, if anyone's interested in looking at videos and so on, there's a fair bit of this footage that's there on our website, and you can actually go in and play a lot of these videos to actually see how these processes are working. So each sort of step and each module has been demonstrated, and a lot of the work, of course, has been published already in the scientific literature. What we want to, of course, demonstrate is we can go a step beyond that. I had someone asking me just yesterday as I was presenting in Adelaide that oh, can you do more than just the gray filaments? Because we'd love to be able to have, filaments and therefore products that can be produced in different colors, and different manufacturers who want to be able to put their own stamp and their identity onto it. So of course, guess what? That's exactly what we're doing now. We're producing these plastic filaments that are of different colors, and the color is also coming from waste. So just think about all the color printing and the toner cartridges, the color cartridges. You know how many times there's a lot of powder that's left behind in your cartridges. You can sort of shake it up and use it a bit more, but ultimately there's a fair bit of powder left behind. So we've actually designed our process with that extra step in there, that we can actually include some of that color that comes from waste. And so all of these filaments that you see have been produced in our own microfactories using waste resources. And indeed, of course, some of the products that you see at the bottom there, the 3D printed products, are products that we make where, consumers, people who make all kinds of cool things from manufacturing consumer goods to aerospace and many other industries who come and ask us, well, here's a design we've created. Could you sort of print this for us? The nice thing, as you may know about 3D printing, is that not only it allows you to produce complex shapes and forms, but in this case, if we can actually produce a lot of these filaments that are highly specialized to meet their requirements, then there's absolutely no limits in what you could well incorporate into those plastics. So it's not just about creating a plastic filament, but it's about incorporating metallic and non-metallic particles to enhance the properties. So you can actually sort of break away from that myth that, if it is made out of, waste materials, it must be poor quality. In fact, we're turning it upside down on its head, and we're actually saying, no, wait a minute, you actually can produce and get outcomes that might be better than what you could do otherwise. With one of our technologies, green steel, which we've commercialized, and we use waste tires in the process of making steel, that technology has been commercialized globally now. So it runs not only in Sydney and Australia, but in many other parts of the world, in UK, in South Korea, and so on. All of that, again, is back to the point that, yes, Australia might be a small steel producing country, but the fact that there is appetite for waste materials like tires to be used in the process of making steel and producing green steel to replace traditional resources like coal that go into making steel is basically something that we all share. We all want to see resources that are going to reduce our impact on the planet. So if it means that a manufacturer like steel can actually reduce its coal consumption, bring in renewable and waste materials as part of production, can we imagine a future where we could be using all kinds of waste materials in various supply chains and various pathways? It's not just materials like steel, many other metals like nickel, for instance, again, a very important metal that needs coal in its production. So do we just sit back and accept that we need nickel, so we'll just kind of ignore the fact that there's coal being used in the production of metals like nickel? Well, we can't. We need to understand how the entire manufacturing process is going to become a lot more green in the way we use our raw materials. And if it means that we can use materials like waste tires as we produce green steel, well, there's no stopping. So effectively, it allows us to produce our materials, the green materials, in very different ways, and looking at feedstock that can come from so many different sources. So the fact that we've used waste batteries that contain zinc and manganese, the fact that we've used nickel metal hydride batteries to be able to produce nickel, and we in fact have shown that we can reduce various oxides into a metallic form in a far more efficient manner. Our steel makers have basically shown that it's not just about recycling tires, but it's actually shown them that their process of producing steel by using tires is a lot more efficient compared to using traditional coal-based carbon. So most people would have sort of asked the question, which people did ask us at the start, you're using tires. Is that going to cause a problem? Is that going to contaminate your steel? Is that going to do? Of course there are challenges. I'm not saying it's easy. It's not just, we'll just replace this by that and we'll all be good. Of course there are challenges. But the fact that all these years on, commercial production of green steel is happening across the world, and steel makers are actually showing that it is a far better and a more efficient process over and above just the fact that we're recycling tires is one part of it. But the efficiency of steelmaking process means we can truly deliver win-win outcomes for everyone. The environment wins and the manufacturer also wins. And I think to me, when you can truly achieve that kind of win-win outcome, then people are going to be really motivated to do it. So I've got limited time, but I'm going to just skip through some of these slides just to show you what a lot of these units in our microfactories look like, so you get a bit of a sense of where we're at with these. A lot of the work that I was telling you about with micro-recycling, an example of what we do is about transformation of waste circuit boards. And of course, that selectivity, as I was telling you earlier, comes from choosing the right kind of temperature to produce different types of metal alloys. This sort of picture here shows you a kind of through a camera as we zoom into our furnaces in the middle there at high temperatures. You can see how we are transforming. On the left-hand side, we've fed in our circuit boards, and of course, on the right-hand side, you're getting different types of metal alloys. The fact that you see differences in different colors there, they are reflecting the different chemistries, whether they are tin-rich or indeed copper-rich. And of course, a lot of this detail has already been published. Just a little bit of further sort of zoom in into what are the kinds of temperatures from 500 to 1,000 in those cases. We are, of course, moving forward in terms of creating these microparticles that we need. And of course, smaller than that depends on the need of the day. So if you want to use it, for example, for 3D printing, again, for metal 3D printers, there's no reason why you shouldn't be using reformed particles coming from waste, and that metal then feeds into production through 3D printing for metals as well. So all of those are pathways into the future. We've got, of course, another sort of example there that you can actually see the scale. But I wanted to come just quickly to this part. I was telling you about the toner powder, and just to again show you some of the images there where we've got the feedstock, which is the waste toner powder that I mentioned to you earlier, very rich in iron, so it is a really useful ferrous resource. And you can certainly imagine how we can effectively transform those materials into iron of high quality. What that then means is for a metals producer, if you're interested in bringing on board really useful, good quality feedstock of iron, why wouldn't you use this type of input? It helps the environment because you wouldn't want to throw that into landfill. And of course, it helps the producer of metals. So what all of this means, if we were to pick up recycling in Australia, what does microfactory actually mean for? Let's pick up these two examples. On one hand, you've got the person who's got all this e-waste, the toner powders and the plastics. And then on the other hand, you've got basically a metals producer. And if that model works in Australia, it can work anywhere in the world. It means that we can enable the transformation. We've got to think about, of course, all the details that go in between the two. But that supply chain between an e-waste recycler and a steel producer who otherwise, under normal circumstances, would have never, ever interacted with each other, suddenly have now become best friends, right? You've got a situation where people are now helping each other. If I'm an e-waste recycler, I don't want to waste money putting some of my waste into landfill. But if I'm a metals producer and someone's offering me good quality ferrous resource, why wouldn't I use it? So you've suddenly got a situation on the left-hand side where all we did, for instance, in times before what we're looking at now, we might sort it, send it somewhere overseas, and it comes right back to us as consumers in Australia. Look at the scenario B over there, what we're talking about in this new situation where we are encouraging and promoting circular economy and new developments to take place, where our recycler has actually added on a very important function. They're no longer just sorting, they're actually operating a microfactory. They're transforming these products into useful resources, which of course enables another producer. So in this case, it could just be the filaments that go to the consumer, or as we were talking about, you could have a whole series of microfactory in there, where they then encourage subsequent manufacturing. So you can just imagine the ripple effect that this can potentially cause. And so from our point of view, really the important message in all of this is that we know that there are challenges and complexities in our waste materials, but what we are hoping is that if we can show that this kind of ecosystem that we are creating in Australia can enable us to deliver technological solutions for manufacturing on a small scale in what these microfactories can do in Australia with businesses who actually had not even thought of themselves as manufacturers, collaborating and working with well-established businesses who can see themselves setting up a whole range of satellite operations, we're suddenly shifting the way we think about manufacturing. So microfactories hopefully will enable all of us to be able to start to unleash our imagination and think how we might be able to enable manufacturing that delivers better outcomes for our people and our planet. Thank you very much for having me. Thank you.
Veena, I think we still have some time for a few questions.
Thank you very much for the interesting talk. I just wanted the filament, it will become product, and that product will become a waste. And then that waste can then we use it again. How many times into the cycle have they tried? It's becoming like a rechargeable battery rather than primary.
Yeah, you know what? That's a good question, because that's exactly the kind of work we are doing, and not just with our filaments, but with the whole range of other materials. You're absolutely right that what we need to be able to do is be prepared well ahead of what industries are going to want us to do, which is let's put back into manufacturing, see the quality of these types of materials. So one of my PhD students is actually looking at exactly that. How many times can you actually put it back in? Because it's not just about making the filament, right? You've got to actually put it into subsequent manufacturing. So testing that whole portfolio is important. Now, of course, as we know with a lot of polymeric materials, there will come a limit where the quality of the material will degrade as a result of thermal processing. So it's no point sort of producing a low quality output. What we then do afterwards, so let's say it has had several lives, 3, 4, 5 times, or whatever it is that we show is feasible, what you can still access at the end of that sort of continuous cycle is you can still access carbon and hydrogen. Remember, I said that we're looking at its pathway ultimately into steel making. So what we are doing is creating that other product that then becomes a feedstock for a completely different industry, because in that case, you're not after it as a plastic, but what you're rather looking at that resource is an alternative form of carbon instead of coal for the steel industry. So the benefit that these plastics have is that they usually will have carbon and hydrogen in it, and that's why they are such useful feedstocks. And they are actually better for the steel industry because of that very reason, that they contain a lot higher levels of hydrogen compared to coal and coke, and that's exactly why they are so much more efficient.
So the metals will lose their strength,
No, I didn't have the time to get into the details, but the way the process works in the steel industry is that we're not actually using that carbon and hydrogen as part, directly injecting it into the metal. It goes into a layer on the top of the metal surface, which is slag. In the slag, you've got iron oxide. That carbon and hydrogen actually then converts iron oxide into iron. So as far as the metal is concerned, by the time the metal has been produced, it has no memory of who its parents were, if I can put it that way, right? So the fact that its parents were, a carbon that came from coal or a carbon that came from these types of waste resources, it doesn't matter, because ultimately it's the chemical reaction that then converted that iron oxide into Fe, and that's why it has no impact.
That's very interesting talk. Very interesting the idea of reforming the waste. In terms of the risk, we've already had a lecture about assessing the risk of introducing new technologies. Based on why in a few slides back, you're heating up the toner and then it generates a carbon monoxide, which is I think it's not really good gas to release in nature. And so you're heating up the PCD4 in 1,000 degrees or even more. And I think because e-waste is a kind of untraceable, we don't know who from manufacturer. Is it safe to burn that temperature enough? So that sort of risk, how do you assess?
So very good question. So let me just sort of give you scenarios in traditional manufacturing. In traditional manufacturing, when you're actually, let's say, smelting, copper smelting or whatever, when you actually have oxygen present, that's a very different scenario. That's where you are actually burning and combusting. Remember, here we're talking about carrying out these reactions under conditions where we do not want oxygen in that environment. In fact, the reason why this technology and the process of thermal micronizing works so well is you notice from the pictures that the metallic droplets that we got in that one step were not oxidized. They were highly clean materials. So we actually do not have oxidation. And in fact, the temperatures that we use here in the production of these metals, remember I was talking about the selecting, and that selectivity is that you actually only select the temperatures that you do need for transformation. So unlike, say, for example, a copper smelter that might work at, say, 1200 degrees Celsius, in all of these, you only target and focus on those temperatures that you need to create that relevant alloy. So if I know that I want an alloy which is tin-based and I can produce that alloy at 400 or 500 degrees Celsius, I am not going to unnecessarily take my circuit board up to much hotter temperatures, which is the reason why actually from an energy perspective, it in fact ultimately comes back and saves you that energy. So in all of the processes, you've got to remember, of course, we are ultimately going to be dictated by what thermodynamics decides for us, right? So when we talk about temperatures, traditionally when we talk about iron oxide being reduced to iron, so I'll come and address your other question, in a steelmaking furnace, that is the normal temperature at which iron oxide gets reduced and you produce metallic Fe. Because of course the temperatures for reduction, for producing Fe are those types of temperatures. So all of these gases that you see in there are actually utilized in the system and they are not controlled and put out into the atmosphere because think about it, CO gas, hydrogen gas, these are all reducing gases. So you actually can use them quite productively in carrying out subsequent reduction reactions as well. So it's all about how you use the materials as efficiently as possible. So that's why when we talk about these toner powders, for example, and in that particular paper, what we show is that even the resin that is there, which is the polymer in the powder, is a very useful polymer. And the proximity of a lot of these materials on a small scale makes the reactions a lot more efficient. So, but a lot of that data is there if you are interested in that.
I think we're running out of time, so there will be coffee outside, and I'm sure Veena will stay for a few more minutes to have a chat with any of you who's interested. Let's thank Veena again.